Hi everyone, here's the video for 10.1. We're going to be talking about composite functions and inverse functions. So composite, you may have used that word outside of math, like a composition of music, a composite field. Basically, a composition of music would be, a piece of music that is incorporating a lot of different sounds. So you're making one sound out of many different sounds. Or a compilation video, sometimes you hear it phrased that way. So if you're watching videos on YouTube, maybe sometimes there's a compilation video, which is one video made out of many, many videos, right? So for composition functions, it's basically a new function made out of at least two functions. So we have this notation here. This means f composed with g of x, and that would exactly correspond to f of g of x. If it's stated ever g composed with f of x, then that would be equivalent to g of f of x. So for this first one, we have functions f and g, and what I want to do is figure out this composition function f composed with g of x. So this would be equal to f of g of x. So what I'll do is I'll literally take g and use it as an input for f. Okay, so replacing any occurrence of x with g. So instead of just x squared, I have negative x plus 6 squared, and then I still need to subtract 2. So I'll go ahead and expand this. This would be equal to negative x plus 6 times negative x plus 6, and then minus 2. Foiling, we get x squared. Then I would get a negative 6x and another negative 6x, so negative 12x. And then here I would get a 36 and then subtract 2. So I get plus 34. This would be the composition function. Let's go down to part 3. So what if I wanted to take f composed with f, and then not only that, but at the end, I'll evaluate that at 4. So this would be the same as f of 4. So something I can do with this numerical case is just first find f of 4. So f of 4, maybe I'll do that over here. F of 4. How do I do that? Well, in the function f, I replace x with 4. So 4 squared minus 2, this would be 14. So f of 4 is same as the number 14. So f of 14 would be the same as f of 4. So I can plug in 14 now. Get 14 squared minus 2. 14 squared is 196. 196 minus 2, this would be 194. So there's this notion about one-to-one functions. This is kind of inching us towards this idea of inverse functions. So for a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So if you remember, we had the vertical line test for functionality. This idea corresponds to what is a horizontal line test. So if a function passes a vertical line test and then goes on to pass the horizontal line test, then that function will be a one-to-one function. The thing about one-to-one functions is when we're looking for inverses, only one-to-one functions have inverses. So here's that horizontal line test I was alluding to earlier. So just looking at a couple cases. So here is a function, right? It would pass the vertical line test, but it would not pass the horizontal line test. Right, it hits twice. So this would be a function, but this is not a one-to-one function. So no, determine whether each graph is a graph of a one-to-one function. So I'll just say not one-to-one. Sometimes this notation is used. For part B, yep, it would be a function. And if I imagine drawing a horizontal line anywhere, we're just going to hit exactly once. So yes, this would be one-to-one. Here, this line, it would be a function. And if I draw a horizontal line anywhere, it'll hit exactly once. So this would be one-to-one. Here, this is not a function. So if it doesn't pass the function test, it's definitely not going to be a one-to-one function. So I'll just say not one-to-one, but it's not even a function. Here, we don't pass the vertical line test. Even though it does pass the horizontal line test, it's not a one-to-one function because it's not a function. So not one-to-one. I'll just say it that way. All right. So here's how we find one-to-one functions. So first of all, find one-to-one. Here's how we find inverse functions. The function needs to be one-to-one for it to even have an inverse. So assume that this function is one-to-one. It is. You could graph it if you want and see that you have this sort of line. So you would have, yes, this would pass the vertical and horizontal line test. So an inverse function would exist. So now I'll go ahead and find this. So step one says to replace f of x with y. So instead of f of x, I'll just write y. Step two, it says interchange x and y. So just literally switch them. So I'll have x equals 10 minus 2y. That's step two. Step three is solve for y. So x equals 10 minus 2y. I'll go ahead and start solving for y. So maybe I'll subtract 10 first. So x minus 10 equals negative 2y. And then I'll divide by negative 2. So it's looking like negative 1/2 x plus 5 equals y. Step 4 is replace y with f inverse. So this is our notation. Our name for the inverse is f inverse. So we have negative 1/2 x plus 5 equals f inverse of x. I'm going to go shut that door in case you're hearing all that noise. Okay. So I'll leave example 4 open. Of course, I'll attach solutions to all of these. Here's a picture of kind of what will be going on with a function. So if this is our original function, and then imagine this is our inverse function. Sorry, I got that backwards. Here's our inverse, here's our original. Then they will always be symmetric across this y equals x line. So that'll be the geometry that we expect for these. Okay, I'll mention more about that in a second. So this one says, find the equation of the inverse, graph f and f inverse on the same set of axes. Okay, so step one, by the way, this would be one-to-one, right? If you imagine graphing this, you would have something that looks like this, and that would pass the horizontal line test. So this is one-to-one, so we can move on and start finding the inverse. So step one said replace f of x with y. So there's step one. Step two was literally switch x and y. So I'll have x equals 5y plus 2. Step three was solve for y. So I'll subtract 2 and then eventually divide by 5. So divide by 5, divide by 5, divide by 5. So I get 1/5 x minus 2/5 equals y. And then step 4 was simply rewrite y as f inverse. So we have 1/5 x minus 2/5 equals f inverse of x. That would be the inverse function, and then we'll go ahead and plot both of these on the same set of axes. So I'm plotting f of x equals 5x plus 2, and then I'll plot f inverse of x equals 1/5 x minus 2/5. Okay, so using the slope-intercept form, here's the intercept, and then it says go up 5 and over 1. I'll make that point. I wish I had a ruler. I guess I'll use this paper. This might work. Okay. There's that graph. And now for the red one, I'll have negative 2/5. That's about negative 0.4. So can't do that exactly, but I'll just say it's right about there. And then I go up 1 and over 5. So up 1, take me right about there, and then over 5. And I'll make this line. Okay. So they should be exactly symmetric across that y equals x line there. Okay, there's our graph. One more. Go ahead and do this verification. So there's a way of checking whether your inverse is actually correct, and we haven't done that yet, but this is the check. So we need this and this to happen, or else our inverse is wrong. So what this is saying is compose. So if you compose f inverse with f, you should get x out of that. And then if you compose in the reverse order, you should get x out of that. If both of those are happening, then indeed this inverse is the inverse of f. So this is a check. It just says show that if this is our function, that this would necessarily need to be the inverse function. So I'll check this one, and then I'll check this one. If both of those are true, then this thing is the inverse. So for that first one, we need f inverse composed with f of x equals x. We want to make sure that this is happening. Keep in mind that f inverse composed with f of x would be the exact same as f inverse of f of x. So for this first one, if I take f and plug it in to x. This would be the check. So f inverse composed with f of x. I'm taking 4x minus 1 and replacing x with it. So I'll have 4x minus 1 plus 1 over 4. So after I do that, the 1's cancel, and I have this is equal to 4x over 4. Now the 4's cancel, and this is equal to x. So that's good. That's the first part of the check. So I just did this one. So that first one checks out. But the other part of the check is necessary. So now I'll take f composed with f inverse of x and make sure that that also equals x. Keep in mind that this here, f composed with f inverse, would be the same as f of f inverse of x. So f of f inverse of x would be the same as taking now, so for this one, I'm taking this and plugging it into x that direction. So I'll have 4 not multiplied by x, but times x plus 1 over 4. And then I still need to subtract 1. So when this multiplication occurs, these 4's cancel. And we're left with x plus 1 minus 1. Then these 1's cancel, and we get x. So that's a good verification here. And this basically would be your proof of that. This would be you showing that. Just this work here and here. All right. Talk to you next time.